I know.
Tomorrow. Possibly in the morning. You may have to use some of this stuff. Yeah. So I'm gonna have to move.
Not yet.
You didn't have.
Yeah. Let us come back Saturday morning. Oh, I just have
Oh yeah?
One was with, Blackhawk Construction and Set Design
I'll take it over.
Alright.
Okay.
And the other, the guy.
I just had to sign it up for it.
Yeah. You might want to control the because of that. Okay, so that it's like
Make it so that you don't see your, like, the floor plan, the.
Oh, right. Yeah, all of your floor plans, when you create them at the first part, there's a part here that says underlay, and it's showing you the floor plan below. If you just change that on scroll it up.
Thank you, drive me insane. It's nice if I can align to it so that I can remember when
All right, well, we'll go ahead and get started. Couple quick questions that I've had just come up here. Whenever you're on a floor plan, some of you might have noticed that you actually see the floor plan directly below it. And by default, every time you create a new floor plan, Revit automatically shows you an underlay. And if you're in a floor plan view and you click on the level that's associated with the browser, and then look at the properties under underlay, it'll show you by default to show level 1. But if you just scroll up all the way to the top and then select none, that'll take away the underlay. So if you're seeing kind of grayed out lines from floor plans below, that'll help you. The reason Revit does that is it thinks that you eventually want to align things from floor to floor, and it's just a method for looking at a floor below and kind of looking through your paper. Today I actually want to introduce column grids and columns and even beam systems. Any of you have had to do a framing plan yet for your studio? Or you're supposed to pretty soon?
Yes.
Have you guys done one already, or are you about to?
Done one already.
Done one already. Okay, I'm going to show you how you could have done it pretty easily. The other part I want to get into is introducing just how to deal with custom railings and how to use the railing tool to also just make kind of simple sunshades that can follow basically any kind of shape. And we can look at making extrusions along paths just using that railing tool. So the first thing I want to do is, if you guys have your hotels open, you might just kind of look at a floor plan. Obviously mine is not as complete as what you guys have been working on at the moment. But I'm going to be looking at level 4 here, where I've actually placed a few rooms. And essentially, once you get to a certain point in your design where you have actually worked out your module of where all of your rooms are going to be, so everyone should be kind of working towards that point at the moment where you've worked on your 2-bedroom unit as well as your guest bedroom or guest room, and you have some form of a module set up that may stack on from floor to floor, or maybe it doesn't. But at some point, we have these twisting towers, or these towers that slope with their exterior facades, but we also do have to put some structure in it. And we need to show the structural engineer exactly where we prefer to have columns, and then let them come back and tell us otherwise. Essentially, once you get to that level of detail, it's probably a good idea to start your column grid. And a column grid is basically just like your level grid. So if you're in an elevation, and remember we've set up all these datum lines which are horizontal levels, in the plan view, your grid lines become your datum lines in plan that allow you to align things from one floor to the other, or also they allow you to pinpoint where columns need to be, and then also during construction documents or even during construction administration when your building's actually being built, everything ends up getting referenced off of a column line. So contractor's going to give you a call and they're going to say, hey, by the way, I'm looking on floor plan level 4, and I'm looking at near column line A1, and here's this kind of problem or this kind of question. So the datum and the grid lines end up becoming kind of location markers, like you would find essentially even on like a map. So under home, what you would want to do is you'll see that in a floor plan view under datum, we have the levels are grayed out because we can't place those, and then our column grid is shown. And I'm missing my copy. Excuse me. And what we can do is immediately start placing column grids. And the strategy with column grids is that normally you would try to place them, you'd find kind of a common, I guess, angle, if you will, that's associated with most of your floors, or maybe it's the floor edge, or maybe it's actually the way that your rooms are oriented. Because I would imagine, even though your tower is kind of twisting from floor to floor on the exterior, there might be something more consistent on the interior that you could begin to align with. And if not, then it might just be a good strategy just to make a straight horizontal and vertical grid that we can reference. So looking at the way that my floor plan is right now, like I would probably just choose, because I've got this straight line on the back, just to do a vertical and horizontal, but I really want some of my column grids to probably follow exactly where my rooms are actually angled as well. So it might get a little complicated, but let's just go and start with kind of an easy side. Well, we'll just start on the left because that's where A and 1 need to be. You can see as I'm trying to hover over, it's trying to align with the actual walls. I can't get a nice straight up and down. Let's see how it's automatically trying to be parallel to any of those walls at the moment. So I might start down here at the bottom. That's not going to help. Wants to really align there. But you just basically draw, once you hit the column grid option, you're basically just drawing a line, and you may have to tweak it a little bit to figure out where your grid is going to be. And you can actually place it first, and then later on, align it. So I might decide that really column line 1 may want to actually align with, after I've placed it, maybe actually wants to be at the middle of that wall. And so this is column line 1. Now what Revit does is you can't name a column line exactly the same, so you have to basically have a unique name each time. And immediately, as soon as you either hit copy, and I might copy this over and see what my next module is. Maybe I go over, see 3 rooms might be too much for me because it's 40 feet, so maybe I want to go 2 rooms over. And once you place the next column grid, you'll see that it automatically starts counting for you. So you've got number 1 and number 2. And again, I might come back in here and make sure I align this a little bit better. So I've got column 1 and column 2. I'm not going to really worry about the exterior column grid at the moment, but I might, well, at some point I'm going to have to deal with the way that this is twisting. So let's just go ahead and follow the exterior. I'm going to go back to my column grid, and I can also use that. You can see that there are, you can actually do curved column grids, and then also drawing a straight column line, and then you can also pick a line. So I could actually pick this particular angle that's associated with the exterior of this side. And you'll see that when you pick your column grid, if you just hover over and left click on it, on one side you have a bubble, and the other side you do not. But there's a little checkbox that you can check, and that'll make the bubble appear on the other side as well. Now, I might want to start to rename these a little bit. You can just left click into the number, and maybe for right now I'm going to call that lowercase a so I can make this one go back to 1. Make that one 2, I'm going to make this one 1, and then come back and make this one 3. So you can just click into any of the bubbles, and on either side of the bubble, on either side of the column grid, that number is going to update. And you can also drag your column grids so that they lock to one another. I can unlock them, and that would make it so that I could move, so that column 1, 2, and 3 are not exactly in line. Or if I start to move this up, you'll see that you eventually get an alignment tool, this dashed line. That as soon as you snap to that, it automatically figures that you want those two to lock together. And then when you start to move your column grid, you'll start to see that all the column grids will move up and down together. Now this column grid that's right on the exterior, I probably want to have it right at the exterior of the slab. So I might just move that, probably 2 feet in. The structural engineer would tell you how far to move in. And then I'm going to make one last column grid, and this one will be associated with this angle. And this might not be as cut and dry, all the way from floor plate to floor plate, but this is a way to start. You may have to figure out kind of a common angle that might at least work with all of your floor plates. And the way you could do that would be to look at your site plan, if you still have one. And that would allow you to look at all of your floor plates together, and you can start to see that, really column line 1 here, the way that all of my floor plates are moving in. I might have column line 1 only on floors, 1 through 20, but eventually, I'm not going to be able to use that column grid anymore, and it'll start to shift in. So anyway, just you'll start to see where you might need to place a column line from time to time. Go back to my level 4 where I'm working. And I'm going to do another column grid, and this time I'll pick associated with this angle. And I can also move this. And the column grid's really something that you want to be working out, and you're trying to figure out where it works best with your design. So we're not going to solve that here in class, but one thing to note is that typically from left to right on your page would be numerical column grids. So you'd have 1 through 10 or 20 or however many you have. In order to make a grid, you have to apply some line that's going in the other direction. And Revit's going to automatically try to start numbering based on where you left off left. So you can see it automatically made that one a column grid 5. I'm going to move this before I continue. Let me move it in. I'm just moving this in 2 feet at each time. But then in the vertical direction on your page, looking at it in plan view, you would, from top to bottom, start introducing letters. And so I would have a capital A. Where's my number lock? There it is. Number lock, caps lock. And then I'd be moving down from A, B, C, and so forth. And so once I change that to an A and I copy this down, you'll see that the next one will automatically populate to be a B. So it tries to at least figure out where you're headed with your numbering scheme. Maybe my next, I'll do one last one here. So once you have some kind of system worked out, you've got a couple different grids here. I might probably have another one I should probably put in between here. And you know, kind of the general rule of thumb is that you probably don't want grids too much further than 30 feet on center. But, you know, you're obviously could be 33 feet if that works for your module, or 34. It's just once you go above 30, then the steel sections that are going to be required, your W members, end up becoming a little more atypical and not as efficient or economical, I should say. And we're going to, you know, you'll start having a structural engineer will be sizing members that are a lot larger than, you know, typical, and that gets expensive when you start to multiply that over, you know, 40 floors or however many different floors that you have. So you might just try to find some kind of common ground, something near 30 feet, and you can see that between column lines 2 and 3 it works with my module, and it's more like 26 foot 4 inches, and because if I went to the next one over it was too far. Now, having a set of grids, and you know, again, you'll figure out the best way to lay that out. Whenever you click on whatever floor you've laid those out on, these are actually 3D grids. They're kind of actually 3D work planes. And so if you were to click on level 9, for instance, you'll see all those grids again. And the bubbles might not be exactly how you left them from floor to floor, but you do have each of the referencing grids that you can see from floors, you know, 1 through, you know, level 40.
Jeremy, what did you dimension between columns,
Well, the dimension is only going to happen if you're able to dimension from a parallel column grid to the other. If I'm trying to dimension from here to here, you know, making an actual dimension would not make any sense actually because of the angle. So what you'd actually be doing is dimensioning to the intersection. So you can see how I can actually measure to the intersection, and then I can actually strike a dimension. Because from intersection to intersection, because that one grid is angled, you obviously have different dimensions as you proceed. Revit only likes you to go to parallel objects. Now once you have a grid, what that allows you to do is we can actually start placing columns. And one part that we haven't really gotten into, we've looked at structure as an adaptive component and all these other customized components that we've made in the conceptual design environment, but Revit comes with its own set of already ready to place structural adaptive members that could be steel, could be steel trusses, can be wood, can be all these different materials, even concrete. And these are the same tools that you'll find if you happen to open up Revit Structure instead of Architecture. Revit Architecture is what we've been working in. If you were to open up Revit Structure, under their Home tab, they would have all of these particular tools plus a whole another array of, you know, options that have to do with calculations and so forth. But to place a column, if you look at the Structural tab, and under Column, we want to place a structural column. You'll see there's two options under Column. There's Structural Column and Architectural Column. The difference is a structural column has structural properties, and you're actually going to be loading it from a structural table that has all these properties already embedded in it. You can't really edit those properties because, you know, it comes from, you know, the Steel Institute and, you know, wherever the product is coming from and the different tables that you're looking at. An architectural column is actually, you know, basically something that you would put around, or it'd either be decorative or it'd be something that you'd put around a structural column. So, for instance, in the salon, there's steel columns that are inside those round columns, and those round columns are just basically architectural columns that make it look like, you know, they were actually round steel columns. But there's actually W members that are holding up the clear story that are in there. So what that means, though, too, is if you look at your visibility graphics, VG, this confuses a lot of people when they're using Revit, is that you'll see that under visibility, there's under the model categories, there's columns listed. If you scroll down, you'll also notice that there's structural columns. So what would have been nice is if they would have called columns up here architectural columns. A lot of people will try to turn on and off structural columns, and they're turning off this one that just says columns, and that one's only controlling anything that was made with the architectural column tool. So if you're trying to deal with your visibility graphics and if you're doing anything structural, it'll have the word structural in front of it. So placing a structural column, I'll click on structure, and you'll see under your properties when you look to the left, there's only like 2 options. And another question I get a lot is, my Revit only came with 2 possible columns, how do I actually get more? Well, the reason why Revit only has a few in there, and this will be the case for everything structural, so even if you're placing a beam, if you're placing any kind of concrete column, and so on and so forth, you're basically only going to have 1 or 2 items because it wants you to start with something and then you need to load more properties or more elements into your environment. If you try to load in every single W member that's out there, your model, you'd be starting with a pretty large file at the very beginning. So when we click on structural column, you'll see that everything grays out, but there is a tab up here for loading a family. So we can click on load family. And then again, looking at the actual folders that are in your US Imperial Library, again, you might want to click on columns to go in there and try to find a column to place. Well, again, you're going to see that these are just basic architectural columns, and of course they give you the Doric column and all those types of things. We want to back out of that. You want to actually scroll down and get to the structural folder. So if you're in the structure tab, you want to be loading up anything in the structural folder. And then you see that you have columns, foundations, framing, and trusses. And click under columns, and then it even breaks it down further into concrete, precast concrete, steel, and wood. So then we can click on steel. And then you can see that there are basic shapes that if you just left click on them and scroll down, you can look at the thumbnail. But down at the very bottom is a W wide flange column, which is probably a very typical W column or a column number that you'd use in most of the buildings nowadays. So we'll click on W wide column, and when you hit open, you'll be presented with a new, basically a table. And this is another way that families can actually be created, and I'm not going to go into how you can actually make one of these. It involves a little bit of text editing, almost like coding. But you can make families actually pull up this menu of options. And what it's showing you is all the properties that are associated with the family type. And then it's showing you all the family types that are possible. So you can scroll down, and you can see you can go from W4 by 13s all the way to W44 by 335. And these come straight out of the steel structure book. So if you still have yours from your structure class, all of these, the W, the A, the lowercase d, the BF, TW, TF, and K, those are all dimensional abbreviations that are referenced from the structure book. So for what we're doing, you might try to just find kind of a typical column size that might be more like a 12 by, let's go to 12 by 35 sounds good. And it will show you, you've got your depth and your width, and actually maybe I should probably be more like a 12 by 65, because you can see it's more like a 1 by 1 column. So that might be good planning purposes, especially at the very start of your design. You actually want to throw in some kind of column size in there that you're going to have to eventually plan for. So if you select the type over on the left, and I just clicked on 12 by 65 and hit OK, it'll say that you want to overwrite the existing version, and you say yes, overwrite the existing version and its parameter values. And all it's doing is now allowing you to select from your pull-down menu. You now have loaded in the 12 by 65. Now when you click on 12 by 65, there's a couple different ways that you can place this column. And the first would be you could place it at a grid. So you see at the very, at the top here, you can place it at the grid. And what that would do is you can select the two grid intersections, and as soon as you do that, that column will get placed there. And you'd hit finish, and then I can kind of exit out of that. And if I look at my 3D model, let's see where that.
When I came up with an error says no columns were added to the document.
Did you select both grid lines and then hit finish? Yeah, you need to hit both grid lines and then finish. And then I'm trying to find where my column got placed. So my column, because I was on level 4, it just went from level 4 to level 5. If I let me turn on all my layers again. And so once you place one of these structural elements, and so I've got my column, if you look at it in plan and you select it, you then on the left-hand side have your base level of how far it needs to go. Revit's kind of assuming that maybe the column should just go from floor to floor, and that might be the case, but then, you know, for every floor you've got to align a column above on the next one, and you're going to have to do that 40 times. You might just say, well, you know what, I think this column D at D2 should really go from, might be nice if it went to the ground, so level 1, and then maybe I should make it go as high as it can, so level 41. And then every time I click on a new floor plan, I should be able to see that column. And if you don't see the column, it's because in the course view, so down at your lower left-hand corner where you can decide to make it course, medium, and fine view, if it's course view, every structural member, you're just going to see a single line element, or you might not see it at all. But if you change it to fine, then you see all the shapes of the column. And you know, I might decide that I don't need the column to be oriented in this way. Once you've placed your column, you can also use the align tool, and I can align, you know, if I wanted it to actually rotate to be parallel with that column grid. Now once you've placed a column, what happens now is with the column grid, if you decide later on that you should move your column grid, your column is going to always move with it. So structural elements are going to follow, especially if you've snapped them to the column grid, they're always going to move wherever you've ended up retweaking or removing any kind of your column grids that are already shown. Another method for placing a column, you know, right now I did it by the intersections of the lines, and I'll do that one more time just so you guys can see that. I'm going to hit structure, and I could either hit structure and go through all this process again of hitting structural column and going through that, or I could right click on the column and say create similar, and that'll allow me to create a W12 by 36, and you'll see that at the very top at the options bar before I place it, it gives me the height of where this column is going to go, even since I'm placing it on level 5 at the moment. I might want to start on level 1, might make a good place to start. And then when I right click on this, let me show you a fine view. Right click, create similar, and then I can change my height here to go all the way up to level 41 before I place it. Then I don't have to backtrack and make sure I apply all those properties. I'll click at grids, and then I'm going to click on one grid, and then the grid that's perpendicular to it or going in the other direction that forms an intersection. As soon as I do that, then I have to finish that command, and then I've placed that column. Another method for placing columns is you can also just hit structural column, and I could just place it off into space and then use my modify and align tools to move it into place. And you should be able to see that when you zoom in, you can actually snap to the center line of that column, and then you can move it into place.
When you snap into place like that, then will it follow those grid lines?
Right, so now I've placed all these columns in different methods. If I move the column grid, they all move with it. When you start to align it, it's not really necessary to lock the columns to the column grid, because Revit automatically assumes that if you're placing column grids, you probably want them near a column, so the column's going to move with it or be associated with the column. So that's real quick how you can actually start to place column grids throughout your project. So you want to come up with some kind of module that fits what you're working with, and then you can go ahead and start to place actual columns so that you have a little bit of realism in your floor plan. So when you look at it in 3D, and I can see I've got one column that's not going to work through all my floors, so this column might only need to go up to a certain level, and then eventually I'm going to have another column that's offset, where I'll have to deal with the cantilever. And I'm not asking you guys to be a structural engineer, but we do have to show a little bit of how we're thinking the framing needs to happen. Now that's important because in the office, even though you have a structural engineer that's a consultant outside of the office or sometimes in the office, well, as you're designing, oftentimes we are giving them how we would like the floor plate to be framed. And we might be saying, you know what, I really want this to be a cantilever, and I want it to cantilever off of this column. And then we're giving them kind of a direction of how to start to calculate and size those members. There are some structural engineers that will actually come up with a couple of design ideas for you. But for the most part, you are telling them exactly how you would like your structure to work out. If it's having to do with an architectural aesthetic, especially with how you're dealing with this exterior facade, you might tell them that you don't want a whole bunch of columns, all bunched together trying to figure out how to make this happen. You might be saying, I'm going to have a column, and then I'm going to get to level 10, and then I'm going to offset that column in 10 feet. And so we have to figure out how to make that offset happen. And there's all these different methods that work, and we have to be the ones to give the direction to the structural engineer. That's why you take structures class. In the office, you won't be doing the structural calculations. You won't have to really know that, but we do have to understand a little bit of the systems that we're working with. So starting to show this in the floor plan starts to at least tell the structural engineer what we're thinking, and then they can come back to us and tell us later on if we're crazy or not for trying to propose such an idea.
Can the grid lines be curved?
They can. So they can only be curved in plan though. So when you place a grid line, you can see that it gives you a start-end radius and then a center arc radius. So it's always going to be something that would be more like that. You'd see that kind of more like if you have a rotunda type of floor plan or something that's curving in plan. But it might help you if you have a very curvilinear face on one particular side. You might try to find some kind of curve that's at least real close to how all of the floors are reacting from one level to the other, and come up with a certain radius.
So if the structural engineer comes back and says, you need to move all these columns and they're all the wrong size, you have to manually go and realign everything?
So yeah, later on what will happen is, hopefully your structural engineer is working in Revit, and most projects now, if you say that you're starting in Revit, everyone on the team should be getting on board and working in Revit. But depending on the project, you could have a AutoCAD plan coming back to you or something like that. In most cases, especially on a large project like this, you'd probably all be in Revit, all in the same version. But what would happen is the structural engineer would give you his model after you've given him yours or her, and they would play around and calculate where everything needs to be. And there's actual sections up here under collaboration that I'm not really going to get into because we're not really having the opportunity in this class. But you'll see that there's this option here called copy monitor. And what that is eventually you could copy in what the structural engineer gives back to you. And then every time the structural engineer decides that the grid line needs to move a foot or a column needs to get bigger or resized, this would monitor as you bring in the next model whether or not something has changed in your model, and it'll tell you how to update it, or it should be updated. So it's kind of a tracking mechanism that goes back and forth for the coordination. But to answer your question, what you'd have to do is go back and let's say a structural engineer says this column is not really a W12 by 65, but it's going to be a 103 by whatever. You would then hit edit, load, and load up another column type, and then it would change to that. So I can click on structural, go to columns, steel W member. So I'll just pick that one out of the blue. And you can see it changes to not the one I picked. But then you can go back and then say, okay, wow, that column really grew, and then you have to figure out how all your architecture needs to move around it. So that's why at the very beginning it is kind of nice to start to plan. And at schematic design, I would call my structural engineer and say, hey, based on my grid spacing right now, give me a good general starting point. And they might say, well, you should really plan on just across the board a W100 by whatever, and then at least you're planning for that as you're starting your design. Because what's going to happen is, eventually, so I'm going to have a column right here, or it seems like a logical place that I would need a column. So if I go back to my structure, structural column at the grids of this intersection in here, and hit finish, I'll see that eventually I have a column that's sticking out of a wall. And you're going to have to figure out how are you going to deal with that. Are you going to make a wall completely bypass it on either side, or are you just going to make little bump outs with wall architecture that goes around it and becomes a feature in the room? And so, when you look around in all cases throughout buildings, you'll see, where columns are located, and you're deciding, is this going to be a circular column, or, how are you going to deal with that intersection? That's why at the very beginning it is good to start to plan for this right away, because the worst thing you could do is come up with the perfect floor plan, and then, the structural engineer is going to say, oh, by the way, I'm going to have to put like 10 columns right through that room, and it's not really going to work out with the space that you're trying to create. So anyway, I'm going to just look at this grid right now. I've got grid A, D, and 2 and 3 where I've placed some columns. And I should probably place some at B here real quick. So structural. And we can also look at how would you start to actually create some structural framing that would work through here as well. And I don't know how many of you have had to do a 3D framing model. Have you guys had to do a framing model at all, or you guys just did kind of stick plans?
We had diagrams.
Just diagrams? So most likely you'd probably want to start looking at the actual structural system in 3D and looking at it, and you might be getting this information from your structural engineer. A lot of times you are also kind of doing your own structural framing plan, because there are times when you're working on a wall section that you have to tell the structural engineer that, this beam really needs to be at level, like 5 feet above level 5 in order to make this wall section work out in the detail. And the structural engineer is going to be expecting you to tell them where certain beams need to be as far as elevations are concerned. Especially when you get close to the roof and you're dealing with things like the clear stories or skylight systems, whatever the deal might be, you're sitting there saying, where that beam needs to be in elevation. So I might actually start to schematically start a framing plan. I'm going to change this column back to something not so crazy. And for right now, I'm just going to hit VG, and I'm going to select all of my model categories. I'm going to I'm going to uncheck everything except for my structural items. So all I'm looking at is my framing here. Adding a couple more columns here for realism. By the way, there are also many job opportunities out there for modeling structure and modeling architectural items. Contractors, when something hits the streets and they're actually starting to build something, they'll need their own Revit models, and so they'll ask people, subcontractors, to say, hey, by the way, I need a framing plan built for this model or this particular project, and I need a model for it so that they can start doing all their coordination and their collision, tests and everything throughout the process. And there's a big market for that as well. So even just knowing these simple tools, you can easily create a quick 3D framing plan for somebody, and it becomes beneficial in the construction process as well. Because they don't just take what the architects and the structural engineers do, they'll take that as a basis, but once everything gets into the field, things get engineered even further by the actual subcontractors and the people that are actually building. And so the contractor has to constantly update their own version of a Revit model, and then also make sure that they can size things properly and also visualize how mechanical and structural numbers are interacting together. Okay, so to do a couple beams real quick, there's a couple different methods. You could draw beams. So I'm going to draw beams from column line to column line. I might have them spanning in this direction, the way that my cursor is moving at the moment. And there are two systems. There's just drawing a beam. So you've got beam, and then you also have beam system. The difference is, drawing a beam is kind of a one-off item. You are essentially taking a beam, and again, by default, there's only a 12 by 26 shown in there. We can load up more sizes in the same manner. I'm not going to go into that at the moment, but I can draw, and I'll show here that your justification is at the top, and my reference plane right now, let's see, I'm on level 4. And if I just draw a line from column to column, I need to look at this in 3D. Switching over to my 3D view real quick and doing the same thing where all I see is the structural members. And you can see that this column is now, or this beam is drawn, and of course I make that a little more realistic there. And you draw one member from column line to column line. So you could do that with every single beam that you need. And of course I can't see that column because it's below, but if I just change my view range to see a little bit below level 4, so if I say negative 5 feet and negative 5 feet on the view depth, you can see then I can see the actual beam because it's below the floor plan.
Where did you get to that option?
Clicking on the project browser under, if you just click on the floor, view range, edit, and that's where you change all those visibility options. So again, I can draw another beam. I'll go from grid line to grid line, and I can keep doing that for as many as I need to do in order to make everything work. One thing that's nice about beams and structural elements is that they work a lot like lines. So I can actually click under Modify and use my trim and extend tools and trim and cut beams together. I can also align them. So let's say I draw another beam. So maybe I drew this beam and it's way off from how it should be aligned to this other beam. I can hit modify and then align, and I can align the beams together. You can also do this in 3D, so I could be looking at this in 3D, and I could come in here and also do my trim and extends. So you can see it really starts to act like kind of a stick-built, almost just working with 2D lines. I could actually decide that, this face of this beam right here needs to align with the back of this column. In 3D, I could click on the line and then align. That didn't work. Align. I didn't like it. For some reason, I didn't like how I was dealing with that one. But anyway, for a beam system, you would have to, sit there and do that for every single member. Or if you kind of know that you're going to have typical beam sizes all the way across this particular bay, because normally the structural engineer would probably frame this out where there's a beam coming from column to column at the major column lines, and then in between there's just beams every 6 feet on center. Or there needs to be, 2 beams equal throughout that section. So that's where I'd click on structure and choose a beam system. And a beam system will take you into a sketch mode where you define the boundaries of the beam system. And so I'm just going to use the pick lines command. And the elements are visible because under my visibility graphics I turned off lines. There you go. And I'll just create this boundary. And again, because it's a sketch, I have to make sure I close the shape. And this is definitely where your span direction, we sort of looked at that in the floor plan or working with floors at that one, when we started looking at actually the structural deck and the way that we can orient the structural deck. This span direction will show you exactly where the beams are going to end up spanning. You'll see to the left you have some properties. You have a layout rule, so you have fixed distance. You could do fixed number. I could do maximum spacing. And then I could identify how far apart the beams need to be. And by default it has 6 foot down because that's a typical span that's normally for structural steel deck is to only span 6 foot on center. And so that's why 6 foot is a default. So if I click on that and then exit out, you'll see that it automatically draws all the beams in between those boundaries. And again, you would need to draw the boundary beams and then tagged by default all of my beams that I don't really need that to show up. But now I can go back and look at my 3D, and then you can see that you have that system. And what's nice about that is if you ever decide that your floor plate or that bay changes in shape, I could edit the sketch, and let's say later on, something like this happens where, the actual beam system is going to look like this. When I change that, all my beams will align to the new shape of the sketch. By default, all of the beams are shown, directly right at the level. Most likely you'd have a Z direction offset because you have to account for the thickness of the floor. So whatever your floor thickness is, 5 1/4 or whatever it is, you would type in -5 inches on Z direction, and that would move everything down so that it shows up underneath your floor slabs. So if I click on my floors, BG and floors, and then OK, I can see now that this beam I actually moved where it's not sticking into the floor. Now as a beam system, if I would have, you can select beams individually, or you can tab over and then you select the whole system, and that's actually where I should have changed my elevation. And so this would have given you a 3D structural model of whatever project you're working on in framing, give you some idea of where the structure needs to be and what the sizes are. And the reason that would be important is we all know that we're going to have structure, and you might decide right now from a schematic point of view exactly how deep these beams are going to be before your structural engineer even tells you. And the rule of thumb is usually that the size of this beam should be, if I take my measurement from column grid to column grid, take that dimension and turn it into inches. So this would just be 26 inches and add 2 inches. So this beam should actually be maybe instead of a W12 by 26, I probably need to find one that is structural, go to framing, steel, need to find a W wide flange, and then look for one that is 28 inches deep. So 2'4", looks like that would be a good one to start off with, override. And then when I'm looking at my 3D, I can see that at least I'm planning for that structure before I then also figure out that I'm going to need another 3 to 4 feet for all the mechanical systems that need to go in there, and then I can finally figure out where my ceiling needs to go. So that, real quick, that's all I'm going to really get into as far as structure is concerned, but you can see that you can explore this further with any structural shapes and also wood members and that kind of thing. I want to now go into looking at, I'm going to save this, and you might want to start a new project file. I want to get into railing systems, because remember we have balconies, right? That you guys haven't planned for yet. If you have your floor plate and it's going right up against the facade of your system, because you've aligned or created real floor plates, you should be able to now click on that floor plate and edit the sketch of it, and then you can add in protrusions that come outside of your facade, and you can start to look at exactly where your balconies are going to be and the shape of your balconies. So remember, there is in the project narrative and the program, there is a certain square footage for balcony space. So you'd want to think about that as, and I'll get into that with the next assignment. Let's talk about railings real quick. How many of you have had to model railings on all your projects, in your Rhino models and your SketchUp models, and you have to do the follow me command, and you have to cut a section? You're basically taking what you think the section of your railing is going to be, and all the different heights of where the cable is going to be, or whatever your shapes are, and then you're putting it onto a line that is a rail. So if you're using Rhino, you're using like a sweep, or if you're using SketchUp, you're using follow me command, and you're taking a perpendicular element and then you're extruding it along the path of a curve or a path of a line. None of it works in the same way. We're thinking about the section cut of a railing. When we use the railing tool, I'm using railing right here, we're thinking about a profile that we can draw in 2D. So if you were to think about whatever you're trying to draw that's going to extrude along a path, if you cut a section through it, what are all the parts going to look like? Those parts are going to be determined by a family. And then in the Revit project environment, you're going to select which families you're referencing when you draw a railing line. First thing I'm going to do is just draw, and let's go in. If you start a new project, just in like level 1, go ahead and click under home and then railing. You'll see we get into a sketch mode again. And this is what's called a linear path-based sketch mode, meaning that we don't have to close a shape. Whereas when we've been working with floors and roof and ceilings, we haven't done ceilings yet in here. The beam system, for instance, we had to actually close the shape in order for us to exit the command. In this case, we're just drawing a linear element, and it can be open, and then we can close the command and we're fine. Now, under your default, you have guardrail and handrail types that have already come with Revit. Let's just choose guardrail pipe and just draw a line and exit out, and then look at it in 3D, and you'll see that a guardrail was drawn with all these different members extruded along that path. I could go back to level 1, and if I draw another railing, this time if I make it curved and exit out, oops, I drew my sun shade. My guardrail changes and conforms to the path of whatever the curve is. So you can make that in any shape that you want as long as you can do it in plan view. The other item would be, let's say I had a floor. So everyone click on home, click on floor, just keep it a generic 12-inch floor for now. Just draw a rectangle somewhere. Then draw a slope arrow for your floor. And I'm going to do something drastic, like remember you can click on your slope arrow and change the height offset at the tail or the head. By default it's set to 1 foot. I'm going to do something like 30 feet and exit out. That'll make where I have this very crazy sloping floor that slopes up 30 feet over that distance. If I were to draw on level 1, or I could even look at level 2, click under home and railing. If I click on pick lines and then pick on the edge of this floor that we just drew and hit OK. Keep drawing the darn sunshade. You'll see that, basically the guardrail does not match up with the floor. It still wants to be horizontal. If you go back and edit the path of that sketch, you'll see that you have this option here called Pick New Host. If you pick the floor that's sloping and then hit the checkbox, you'll see that now the guardrail slopes and follows the slope of that floor. Now this only works with stairs, and it only works with sloping floor structures. That's why when we were doing our bridges, I was going to introduce this as a concept, but we couldn't do floor structures assigned to our complex, curvy, sloping mass, and so this railing tool wasn't going to work at that time. So if you have some stairs, I click on level 1. I'm going to draw some stairs off to the side here. Just draw a run of stairs, doesn't matter, and exit out. By default, of course, your stairs want to draw some kind of rail associated with it. But since you've deleted that rail that came with Revit, once you draw the stairs, you look at it in a floor plan view. I'm going to right click on a rail and I'm just going to hit create similar. I can just click on a line for the stairs, pick lines again, and then do the same thing where I pick the new host and I choose the stair, and then I've got a railing that's following my stair. And this should follow your landing and all of the other elements as we proceed. Now, Revit gives you 4 really nice guardrail options. I'm being sarcastic. If you ever are working on a model in Revit and you're trying to present in Studio and you're showing them this kind of guardrail, or if I choose another one, let's say guardrail rectangular, you get the nice vertical pickets, which is the ugliest guardrail you could ever find, or you could do your handrail, pipe, and handrail rectangular, which both of these aren't allowed by code anymore, so I don't even know why they're in there. Essentially, those are your only 2 options. So So you're probably like, well, I would really like to customize this so I could actually get a design, a customized design that works with something I'm trying to do with my studio project or out in the real world in, you know, where you're actually using either cable rail or even bar stock to make your railing. Making them out of vertical pickets and pipe is probably the cheapest and the 1980s way of making guardrails, I would say. So, how do we edit the properties of any of these structures? What we need to do is start to understand how this tool is operating. The first thing is if you select the guardrail that you've drawn, doesn't matter which one, and click on Edit Type, you'll see that a railing has two types of structure. It has a rail structure and a baluster placement. Balusters are vertical elements. Rails are horizontal elements. I got to there by clicking on the rail and then over in Properties, Edit Type. If I click on the rail structure and hit Edit the Structure, you will see that it is referencing, kind of gives you this dialog box, it is referencing a profile. You can see over to the right where it says Profile, and I can click under Profile and click under the down arrow, and it gives you other options for selecting other profiles. These are the section profiles that are being extruded along the path of your rail. So whatever that line is that you drew, this is the section profile that's getting extruded. Then it has a couple other parameters assigned to it, the height off of the host in which that profile is being drawn at. So essentially all of these are 6 inches, then 11 inches, then 1 foot 4 inches on this example. That's how high each one of these profiles are based off of the base. I can hit OK. If I go under baluster placement, you'll see that it is doing the same thing. It is trying to reference a baluster family, which is a baluster and a set of profiles. And then it has some spacing, ways of spacing it 4 feet on center and all that fun stuff. I'm going to cancel out of all that. Under your project browser, off to the right, under Families, expand Families, and you'll see a family type called Profiles. If you expand Profiles, you'll start to see circular handrail. You see a bunch of other different types like fascias and gutters and parapets. You also see wall sweeps and stair nosings. If I scroll up, or nope, I need to scroll down to railings. I'll also see balusters and railings. These are the family profiles that are being referenced by that particular tool. So how do we customize this? Pretty simple, actually. We can just go to View, User Interface, Recent Files, and I'm going to start a new family. We've worked with a number of different families already, but if you scroll down, you see a whole set of families called profiles. There's one that's just called Profile, there's Profile Hosted, Profile Mullion, Profile Rail, Reveals, and Nosing. We have to be drawing our profile in the right template in order for it to be noticed by particular tools in Revit. So the obvious one here is Profile Rail. That would be where you actually draw your section of what you want your rail profile to look like. If I scroll up, I also have baluster, baluster panel, and baluster post. Those are where you draw your posts in one of those family types. First thing we're going to do is just, we're going to customize, we're going to do a quick cable rail. And And I'm going to go under Profile, Rail, and hit Open. And it gives you your crosshairs. It says Rail Centerline and Rail Top. So this is the top of the rail. This is where the rail is going to be placed as you type in the height. And then this is the center line of the rail. Under Home, I'm just going to draw a line. This is 2D, completely two-dimensional drawings that we're doing at this point. So you don't have any extrusions under Home. You don't have any 3D ways of making anything 3D. I can draw only lines. So I'm going to draw a line. And once I do that, I have my draw commands off to the right. If you don't see that, you need to click under the little green tab that says Modify and Place Lines. And then we've drawn with these tools many, many times. I'm going to draw a circle. And I'm going to give it a radius. So I gave it a radius dimension, and I'm going to give it a parameter, R, for radius. And we want these parameters to be types. When we're referencing profiles and we're referencing profile types, in all of the tools, you have to have type-based parameters in order to be able to change and select a different type of family. So what you're doing is setting up a menu of options by making family types. I'm going to set up a couple different radius dimensions. First will be 1/4 inch. I want to click under New, under Family Types, and I probably want to call it 1/4 inch. Because this is what's going to show up in the drop-down menu when we actually try to access it. So you want it something obvious. If you call it Family 3, you're not going to remember if that was 1/4 inch or 1/2 inch or so on. Next, I'm going to create a new family. Maybe I'll call this one 1/2 inch. And I want to change my radius dimension to 1/2 inch and hit Apply. And maybe I'll do a 3/4 inch. And I'm going to go all the way up to 1 inch. This is all things that we've done in the conceptual design environment. And the next one is going to be the last one. I'll just make 1 inch. And hit Apply. So now in your drop-down menu up here, you've got 1 inch, 1/2 inch, 1/4 inch, and 3/4 inch. Exit out of that. I want to apply this dimension with my label to the radius. And now I should be able to change parametrically just this 2D shape to different size radii. I want to save this before I bring it into the project. And I probably want to call it something that makes sense, like Profile, Rail, and then maybe I should call this Cable. Or you could be more generic and just call it Circle, whatever you want. I want to name it something so that when I load it into the project, I now see under my project browser, under Profiles, I should have my Profile, Rail, Cable, and all those different options. Now, under Home and Railing, what you want to do is under Guardrail Pipe, for instance, let's start off with that one. I'm going to edit the type and duplicate it. We always have to start with something. So I'm going to call this Guardrail Cable. And then I can edit the rail structure. And I can change all of my profiles, and I should be able to now select, you can see where you've got Profile, Rail, Cable 1 inch, 1/2 inch, 1/4 inch, and so on. So I can go ahead and select all 1/4 inches if I wanted to.
What are these 1, 2, 3, 4, 5 any reference?
off to the left.
Yeah, is that,
It's just like an Excel, it's a row.
oh, okay, so
It
they're.
has nothing to do with, it doesn't matter what order those are in, because what's changing where those profiles are gonna end up is where you have the height information.
Oh, okay.
And I can actually delete, so maybe I'm gonna come here and just delete some of these rows here for this example. Of course, we can't have a rail like this because you have to have them, 4 inches apart. But I'm just gonna show this. I've got all these at cable 1/2 inches, and when I hit OK, OK again, and then I draw my rail. You can see how I now have a smaller cable type. Let me get rid of this out of the view. And you're going to have them spaced differently based on, obviously, the way that you set up your rail structure. And so to make this realistic, you would actually have these 4 inches apart. So I would do 4, 8, 12 inches, 16 inches, 20 inches, and I'd figure out that since I have to go up to 3'6", I'm going to need a lot more rails. So then I can click under one of these numbers and just hit insert, or I can hit duplicate and duplicate these rails since I want the same profiles, and then I can just keep adding to my heights. So there I've customized that rail. And you could do this with any shape. So right now I just did a circle. With your profiles, the only caveat is that when you are in this 2D world of making profiles, you have to have a closed shape. If you try to bring in something that's not a closed shape and you try to make a rail out of it, you're going to get an error message that says it cannot make the rail, and you're going to wonder why. And if you wonder why, it's always because your profiles are not a closed shape. So just be careful when you get more complex. We'll have to deal with that.
Can you get them converted an angle, like the balusters, 45 or?
Yeah. So right now we've just done a rail section. We haven't done a baluster. A baluster would just be a vertical version of this. I want to show you real quick before we have to go here that if you're using Revit and all you think you can do is make a railing because you're using the railing tool, you need to understand exactly what that railing tool is doing. All it's doing is extruding some kind of 2D element along a path. So you should also be able to make things like a sunshade system. And we can do that by quickly going into two methods here. Under View, User Interface, under New Families, I'm going to create a baluster. I just call it a baluster post. And this comes with a set of parameters, but I'm just going to change the baluster height to maybe something like 8 inches for now. And I'm also going to want to make sure I am in the front view. Don't ask me why, but I think the front view always works for what I'm doing. When you're in the baluster, you're actually in a 3D family. So you're actually making a post. So you're making some kind of extrusion. If I click under Home, I have all of my 3D tools. So yes, you can make an angled post, and you would make it in section, and then make an angled post, and then just extrude it and give it some depth. I'm going to make a sunshade bracket by just clicking on Extrusion, and I'm going to pick the plane front back, and then I'm just going to pick all of these lines and maybe draw one out here, do something like this. And then I'm going to make sure that I've closed this shape. So I actually don't need this bottom line. I might move that out a little bit. So because this is going to be a 3D shape, I need to close it. So I've made this kind of bracket right here real quick. Now I'll click OK, but I'm going to look at it in the left view. And I see my extrusion end and start, things that we've been working with all this time. I'm going to make sure it's about the center line. So I'm just going to give it a negative 0.5 inch and a 0.5 inch. Of course, you could give it parameters. I'm going to save this as a family, and I'll just save this as sunshade bracket. And we can load that into the project. Okay, I didn't do anything special there. All I did was draw a section and then extrude it. Pretty simple. And then if I go back to user interface and recent files and start a new family, and I'm going to make a rail, so I say profile rail, and this time my 2D structure just make kind of a football here. I've made this little foil shape. I made it a closed shape. And if I hit save as, I'll just call this foil for now. Load into project. We can then make, under railing, we can start with a particular railing, and this time I'll just call it sunshade. Call it sunshade 2 for now. And under baluster, I want to reference, you can see I found my sunshade bracket, and I'm going to change all of these profiles to reference sunshade bracket everywhere. I'll hit OK, and then edit my rail structure. The only difference is, in the rail structure, probably need a magnifying glass here, real quick. You see that when we were making a railing, our offsets were all, by default on this particular one set to -1 inch, but they're all the same. But what was changing was the height. So we were actually changing the position of where this 2D element is going to occur in height. Well, if we're doing something like a sunshade element, all of our heights are actually going to be the same. I can just delete this for now. I might make this 8 at 8 inches, but what's going to be changing is my offset of where my foil is located. So I'm just going to duplicate a couple of these real quick and change my offset. And now when I draw, if I cut or look at this in 3D, here's the one I was starting. You can see I now have my railing structure, and of course I didn't complete the rest of the offset, so I'd have to add more profile shapes and then just change the offset. The nice thing about that is you can make any kind of curvy sunshade system as long as you can curve it in plan, or if you have some sort of hosted element that's sloping, I could also slope this up and host it to any kind of element. That's all I got for now. Homework for Tuesday. I know it's holiday weekend and all that fun stuff, but I want you guys to keep working on your hotels. I would like you to start thinking about your balconies. So I mentioned if you already had your floor plates, And let me just load up my tower real quick as an example. If I'm looking at a floor plan view, of course I turned off my floors there. Once you have real floors at any moment, even though you've associated them with a mass floor, you can now edit the boundary and you can now figure out, you know, what the shape of your balconies need to be in order to protrude outside of the mass. So right now I kind of just made this little protrusion right here that allows me to have some kind of balcony that's showing up outside of the mass, so that when I turn all this stuff back on, I have my balcony now that's on the exterior. So start thinking about your room design. You have your rooms laid out. Where's the balcony going to go? And eventually that means, you know, you might have a very complex structural skin system, but you know, we're going to have to poke holes in that, and you're going to have to actually make some sort of straight up and down doorway to get you out of there. And that's why I showed you those curtain wall systems in the last class. So you can just draw kind of a straight wall system. But I don't need you to really figure out that whole design, but I want you to start planning out the area of your and or shape of your balconies. And I also want you to start throwing in your column grid and just throwing in a couple columns and seeing how those might work out. I'm going to start loading up your hotels and kind of looking at everyone's projects individually over the weekend as well, and just trying to see where everyone's at and how far you've been able to get so far. Okay? Any questions at the moment? Kind of a quick class, but the time we have.
Just ceiling times?
Yes.
I can't piece this project in the road, and that's one thing I don't know how to do. I haven't tried to figure it out yet.
I can tell you real quick that if it works a lot like, if you look up on the screen or over here, as long as you have a ceiling plan, you can also have a floor plan, but if I have a ceiling plan of something, when you click on ceiling, there's two methods. So if you actually have a room